Okay, so before we finish this lecture, there is an exercise. The exercise is we want to use the long dataset again. Well, we want to do an ABO method to help us pick a good k-value. And our goal is slightly different. So our goal is we want to pick a k-value to make the false positive rate as low as possible. So remember, for the false positive, it means, well, our algorithm predicted that to be a positive, which is a 1, but actually it is a 0 as a ground truth. So we call that a false positive. We want to build a k-nearest neighbor and then pick the k-value to have so that it has the lowest false positive rate. So you have to go back to the lecture note 05 and then pick any node if you want to, any of the code you want to, and then you want to do a ABO method just as we have done a couple minutes ago. And then we'll come back again and I will show you my solutions. Okay? So you should pause your video here because I'm about to show you my solution. Okay? Okay, this is my solution. So this part of the data, we have already done that before. You below the data, and remember we have to deal with a categorical feature. So for the purpose, it is a categorical feature, and we have to do the get dummies. So we are applying the one hot encoder here. And after that, we will have a data frame of all numerical features. But the next part is we want to do the standard scalar. So after we have done the standard scalar, eventually we will have a dataset like this. So now we have all numerical features. And after that, if you want to do a train test split, definitely. And here is the iteration part. We want to do a k-nearest neighbor, and we want to use a k from 1 to 40 again in this case. So in each round, I build a k-nearest neighbor with the n neighbors equals the I. And then we train the machine learning model, we do the prediction, and the next part is we only want to count how many false positive cases. So how do we find that? So here, so this is the predictions of the current k-nearest neighbor. And what we want to find is for one sample, if that sample is predicted to be a 1 and however it is really a 0 on y test. Let me say it again. If my model predicts that to be a 1 but actually it is a 0 in y test, and then we find a sample classified to be a false positive, right? So we can count that one as one false positive case. So we just go through all the predictions and compare the prediction with the ground truth, which is the y test, and then I want to make it count. So what I did was I created a variable called false positive count. It starts as a 0, and then I visit all the predictions, all the predicted samples. For each of them, I take a look on the predicted value, and if the predicted value is a 1 and it is actually a 0, we find a false positive case. So we increase that by 1. And eventually, we want to do the false positive count divided by how many samples are used for the testing purposes. And then that is the error rate. Okay, so if I want to just plot that, and that is the false positive, the k as the x-axis, and the false positive rate as a y-axis, and this is what I received. So you can see if we increase the k value, and then the false positive rate will keep on dropping. So probably at 25 something, well, it starts to be very stable. So we can pick even higher k values. but the false positive rate will stay that low. So we want to pick a k-value where it stays low. So probably I'm going to pick some value between 20 to 25 in this case. Okay, so well, here is a very quick review. Well, we discussed how do we pick the k-values and why it is important. If we pick a very small k-value, we may have a overfitted model. On the other side, if we pick a very large k-value, and then we may have a over-smoothing problem. So we want to pick the k-value which is just right for this dataset. Okay, and how do we pick that? We have to experiment with many k-values, and then we have to draw a Abel plot, or we want to use the Abel method to try different k-values to pick the right k-value. So that's it for today's lecture.